All right, now we're going to go ahead and learn about the converse of the Pythagorean theorem, which basically means that we're going to prove when Pythagorean theorem is able to work, and it works only specifically on right triangles. So it says the Pythagorean theorem states that if a triangle is a right triangle, then the formula a squared plus b squared equals c squared works. The converse says the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, then that triangle has to be a right triangle. So basically, it's saying the same thing but kind of backwards. Okay, so we basically want to say, are these really indeed right triangles? So if you remember from the last video, we had missing side lengths. So we got two side lengths of a right triangle, and then we had to find the third leg or hypotenuse. So we had to find one of the side lengths. This time you might notice they gave us all three side lengths. We just don't happen to know if it's an equilateral triangle, isosceles, scalene. We don't know what type of triangle it is. So we want to know, hey, is it a right triangle? And the only way to do that is if it fits the conditions of the area of one leg plus the area of the other leg, does it equal the area of that hypotenuse? So that's how we tell if it's a right triangle or not. Now remember, C is important because that's the only one that has to be the right value. A and B can be either value, A or B, as long as it's a leg. Our C has to be the hypotenuse, which again is our longest length. So you always look for C first because that's the most important. So we're looking at the three numbers here, and our hypotenuse is going to be C because that is the longest out of the three sides. So we're going to do a squared plus b squared equals c squared. So a and b don't really matter, so I'm going to call 8 my a. B I'm going to call this 12, and we're going to see, does it actually equal 16 squared? And if it does, that means it's going to be a right triangle, and if it doesn't, that means it's not a right triangle. So we're going to go ahead and we're going to solve those values. So we're going to do our first one, which is 8 squared, and that is going to be 64. And then 12 squared, which is 144. And we want to know, does it equal 16 squared? And 16 squared is 256. So what we're going to do is check if those two add up, if the two areas of the legs add up to 256. So we add those up and we get 208. Well, clearly 208 is not equal to 256. We just proved this is not a right triangle because it did not have the areas. The sum of the areas of the legs don't equal the area of the hypotenuse. All right, next one. We're looking again, A, B, and C. We have to see which one's the largest because that's going to be our hypotenuse. So 26 is our C value. So we got a squared plus b squared equals c squared. So we're going to fill that in to see if it's a right triangle. Because if it is a right triangle, it will fill in to make a correct statement. So we got A, I'm going to call 10. B, I'm going to call 24. And we're going to see, does it equal 26 squared? So we're going to do 10 squared, and 10 squared is 100. 24 squared, which is 576. And we again want to know, does it equal the area of the hypotenuse, 676? So we have 100 and 576, that makes 676. Well, that does actually equal 676. We just proved that this is a right triangle. So those side lengths create a right triangle. All right, and then our next one. We have three side lengths. The first job is always to see which one of them is our hypotenuse. So it doesn't necessarily have to be in order. And as you can see, 48 is not the largest number. 73 is the largest. So our value for C, or hypotenuse, is 73. So we have a squared plus b squared equals c squared. So I'm going to call 55 my a. 48 I'm going to call b. And 73, is our C value. So we're going to see, does it equal the area of the hypotenuse? So we have 55 squared, which is 3,025, plus 48 squared, which is 2,304. And we're going to check, does it equal 5,329? Well, we're going to take the sum of those two areas, and that gives us 5,329, which actually is indeed equal to 5,329. So it is indeed a right triangle. That is how you use the converse of the Pythagorean theorem.